Hello, in this discussion we're going to be discussing law of sines, and this is a technique to solve triangles that are not right triangles. So let's begin with discussing the types of triangles that you might have. Alright, so you can have a triangle that all angles are acute. An obtuse angle, that means we got one angle that is a right angle. Two angles are acute and the other one's obtuse. So if you have a triangle that does not have a right triangle in it, a right angle in it, it's called an oblique triangle. So that's what this case is about. Law of sines will do. It will solve triangles, okay, that are oblique, that have no right angles in them. So these are the four cases. Now, in order to solve a triangle, though, there are some items that you do need to know. Remember, there's 6 parts. There's 3 angles and 3 sides. So if you look at a triangle, when you have one side and 2 angles are known, it's either called angle, side, angle, or side, angle, angle. So when you have an angle, side, angle, what that basically means is you have a side in between known and the 2 angles that surround that side known. Or if you have one side and basically 2 excluded angles from that. So that's case 1. Case 2 is when you have 2 sides and the angle opposite of them are known, so side, side, angle. Case 3 is when you know 2 sides and the included angle are known, that's side, angle, side. So that means you got, in this, for example, in this case, if you have a side, angle, side, you have an included angle between 2 sides, but there's one more side that you don't know, and there's 2 other angles you do not know. In case 4, the 3 sides are known, but you don't know any of the angles. So side, side, side. So let's look at the case 1. Angle, side, angle. Now, what they're doing here, the parts that are in, let's say, angle, side, angle, so that was the ones that are in blue, is the ones that you know. You know that angle, you know the 2 angles and the side between them. Or case 2 is side, angle, angle. So you have a side and the 2 excluded angles beside that one. So that's case 2. Case 3 is you have 2 sides that are in the blue and an angle that's not in between them. So side, side, angle. Or side, angle, side, 2 sides and then the angle between them you know. And then case 4 is all 3 sides that are known, but none of the angles. So those are the situations that you're going to see when you're going to either use the law of sines or possibly something that comes a little bit later, the law of cosines, because the law of sines won't help me with all of these cases. The law of sines is used to solve the triangles which either case 1 or case 2 holds. So let's go back real quick. Case 1, those top 2, or case 2, the first one on the second row. So if you have angle, side, angle, or side, angle, angle, or side, side, angle in that case, the third picture, if you have one of those 3 situations, you can use the law of sines. But here's what the law of sines says. For a triangle with sides A, B, and C, and sides opposites of angles A, B, and C respectively, so the sine of angle A over little a is the same ratio as the sine of angle B over little b, which is the same as the sine of angle C over little c. Now, as in the past, we know that since fractions are equal, that doesn't necessarily mean the numerators are equal and their denominators are equal. So A, B, and C are not necessarily equal, and angle A, B, and C are not necessarily equal, but their ratios are equal. So this is a theorem that we will prove in a bit, at least for one of them anyway. We'll prove in a bit that these two are equal, but we're going to use them right now. All right. So let's look at a little bit more of it. So this basically creates 3 different equations. Sine of angle A over little a is sine of angle B over little b, or sine of angle A over little a is the sine of angle C over little c, or sine of angle B over little b is the sine of angle C over little c. So let's look at that again. So basically, if you have, you basically saying 3 things are equal, then you can break up any 2 ones. You can put the first 2 equal, the last 2 equal, or the first and third are equal. So that's just another fancy way of saying that. And then A, B, and C all add up to 180 degrees. Now remember, we don't have a right angle this time. These are oblique triangles. So they're oblique, and so we don't know, we don't have any 90-degree angles in this case. So let's use the law of sines to solve the triangles that look like SSA or ASA. So we have an angle A, it's 40 degrees, and we have angle B, which is 60 degrees, and we have little a, which is 4. So if you look at we got two angles and one side. So it's going to be angle, side, or side, angle. That's what that one would be. Side, angle, or you could say angle, side. Either way you want to look at it. So how do we do this? Well, we know angle C is going to be, the three angles add up to 180, so angle C is definitely 80 degrees. Because two of the angles are 40 and 60, that's 100 degrees. Make up of 180, 80 degrees is left for angle C. So you got the angles done. That was pretty easy. All right. Then we'll use the ratios, sine of angle A over little a. You know all the angles now. The only things you don't know is little b and little c. So you don't want to put the b and c's in the same equation. We want to use the a's and b's in the same equation and the a's and c's in the same equation. We don't want to use the ones that have the b and c's in the same equation because we don't know either one of those. So that's why we picked these two. So sine of angle A over little a equals the sine of angle B over little b, because A is 4, angle A is 40, angle B is 60, and angle C is 80. We can drop every one of those things into the formulas. And then the first equation, we'll be able to solve for B by cross multiplying. And then in the second equation, we'll find little c by cross multiplying. So in the first one, you cross multiply one way, it's 4 times the sine of 60 degrees. And then you'll end up dividing by the sine of 40 degrees, which is 5.39. And little c, if you cross multiply one way, it's 4 times the sine of 80 degrees, and then divide by the sine of 40 degrees. You'll get 6.13 for the little c. Now I want you to notice something. Now that I have all the sides and all the angles in there, I want you to note that which is the largest angle? Yep, it's the 80-degree angle. Which is the side that is the largest side? Yep, it's the 6.13, which is the side opposite of the 80-degree angle. Not only that, the smallest angle, 40 degrees, has the smallest side opposite of it of 4. So that is not a check, but it sure makes you feel better when that happens. So you're not guaranteed you got the right answers if that's the case, but if you don't have that case, then you know you made a mistake at some point. So all angles that are the largest will have the largest opposite side. So you got to keep those in mind. And sometimes it's just a matter of miscalculating on a calculator. And so you make that mistake and then you're like, oh, that's not the way it should be because this is not the largest side. This should be the largest side, but it's not. And then you go back and plug the numbers back into your calculator and say, oh, you made a mistake on the calculator button. And then it was a different number. And then it does check out. So sometimes it's a very simple check. And it's just kind of a feel-good thing. All right? So let's look at another example. Now we're going to solve, we got angle A and angle B. We have two angles. And we have another side. So if you look at the picture, we got two angles. And the side between them, 5. So this is going to be angle, side, angle. So it's very similar to that last one. 35 degrees plus 15 degrees plus C is 180. So that makes angle C 130 degrees. All right. All right, so we got that one. We got the 130 degree angle in there now. Now we got sine of angle A over little a equals sine of angle C over little c. So we got the A's and C's together. You're like, why is that? Because we have the A's and C's. Okay. We have the A. We don't have the little a, but we have the C's. And using the other one, it's going to be what? Well, we're going to go ahead and solve for A, looks like first. So little a is equals to 5 times the sine of 30 degrees and then divide by the sine of 130. and that's 3.74. So let's place that in there. Now here's where a lot of people will make their mistake. They see that I have B, and they'll see that I have C and A. So I found the A and I found the C, and then they'll try to use the Pythagorean theorem, A squared plus B squared equals C squared, to find the B. Well, that's all good as long as you got a right triangle. If you don't have a right triangle, you cannot do it that way. So A squared plus B squared equals C squared only works if it's a right triangle, and this one is not a right triangle. So you're like, what do you do now then? Well, you just got to use the law of sines once more. So sine of angle B over little b equals the sine of angle C over little c. And then plug the numbers that you know into the formula, the 15 degrees in for the B, the 130 degrees in for the C, and the 5 in for the side C. And then cross multiplying, and then dividing by the sine of 130, you'll get 1.69. And there it is. Now let's look at this triangle a little bit more closely. Which is the smallest angle? Yep, 15 degrees. What's the smallest side? 1.69. Make sure you have a warm fuzzy feeling inside. So that's when that's the case, you know you're probably on the right track. Okay? But again, if you make that observation and it doesn't work out for you, it's probably a quick and easy fix. Like I said, it's probably one of the numbers on the calculator that you mispunched, or you might be in radian mode and you should be in degree mode. And so things like that are the things you look at. It could be a very simple fix on your problem. So, all right. So that concludes this discussion, and we're going to be proving the side-side angle on our next discussion. All right. So you have a good day.